All right, so if you haven't heard, if you've been here before, you've heard me talk about our on-farm research network. But if you haven't heard that Minnesota Wheat does have an on-farm network, so what we are is we're kind of just a network doing on-farm research trials. And so it's funded in part by the wheat checkoff, like Mark had mentioned earlier when he was talking. So this would be some of your checkoff dollars at work. And then we also get grants through different organizations. So right now we currently have a grant with SARE, which is like a Sustainable Agriculture Research and Education Council, that they do a lot of cover crop soil health kind of funding. And we also have a corn innovation grant with Minnesota Corn. And in the past, we've worked with AFREC, the fertilizer checkoff, and soybeans. Minnesota Soybeans has granted us some money too. And so what we do replicated strip trials out in the field. So we usually have a slate of different research projects that we're doing each year that growers can choose from. So that way we can have multiple people working on the same kind of project to get a number of different locations doing the same trial each year. So that way we can group all of our data together to get a better idea of what's going on with different treatments. So the things we did this year, we're looking at foliar copper applications. So this was foliar applied copper at tillering, right around tillering. Same time as you would do your herbicide pass, but separate from the herbicide pass, or that first herbicide pass. So we did that on soils that were testing low in copper. So AgVise recommends adding copper if your soil is testing below 0.4 parts per million. So usually it's on sandy soils. So we wanted to focus on mineral soils. It's pretty common practice in peat soils, but we wanted to look at mineral soils to see if we saw anything there. Nitrogen rates, trying to focus on some high yielding wheat varieties to look at different nitrogen rate response and the profitability of those nitrogen rates. And then how, as we do it over a couple of years, trying to gather it on kind of some higher quality varieties versus higher yielding varieties. We did 2 kind of biological inoculant trials this year. We did Pivot Bio, Return is their wheat seed treatment product. So they were really good to work with. And then we did a Johnson Sioux compost extract, which that was a little bit kind of a different kind of approach to doing a biological treatment. And rock rolling and a few cover crop treatment or cover crop projects that we've kept going the last couple of years as well. So a number of different things that we've got going on with on-farm projects. So unfortunately, I'll only be able to cover a few of them here, but you guys have all of the data in the report that you can take home. So first off, just looking at nitrogen rates on high-yielding varieties. So we were shooting for, in the past, we've done like 95-90, which tends to be a little bit more balanced, higher yielding and pretty good protein. This year, we're also trying to target Buster, Trigger, the super high yielding varieties that don't always have great protein too, just to look at that kind of response as well. So our objective is just compare yield, protein, and then the profitability of those different nitrogen rate treatments. And so we did 0, 60, 90, 120, 150, and 180 units of nitrogen applied. And that would have been on top of what their soil nitrogen would have been. And so we did this. This is our first trial that we've done fully. It's totally application and yield map based. So it's definitely the easiest for growers to do because the machine does all the work. So we write the plots into the prescription map. The floater, we had one anhydrous location, so the floater applies it, and then we just trim the yield maps to those plots. So we make sure we calibrate, at each of the sites, we calibrate the yield monitor before we harvest the plot, and then we can just pull the yield data from the plots. But to get the protein, we go out about a week before harvest and hand harvest the protein samples in the field, which basically involves tracking along the application map and just cutting heads continuously as we're walking through the plot, sticking them in a bag and then threshing them with the help of our university small plot collaborators who were kind enough to lend us their small plot combine to thresh the protein data. And so we had 5 locations this year. You guys have, in the books, you have each of the 5 locations broken out individually, but just for time's sake, I'll just talk about the combined data. So this is combining 7 locations, 5 from this year and 2 from last year. And this was kind of spread out a little bit across the northern part of the valley. I haven't gotten anybody from, down this way quite yet on this trial. But this year was, not a great nitrogen response here. So when we looked at all of the combined locations, we did see an increase in yield and an increase in protein as we increased our nitrogen rate application, as would somewhat be, kind of be expected. So that looked pretty normal, although in some of our individual locations, you could see where there wasn't really a nitrogen response much past 60 or 120 pounds this year. Partially, I don't know if it was just partially because it was dry, or if it was also, I don't know if the being a little wetter earlier in the season and drier in the later half of the season, if the roots were just going down and pulling up that deep moisture and deep nitrogen that was below, deeper than 24 inches, which is probably where it was getting all of that extra nutrition and water to get the yields that we did this year. But I think the interesting part of the story is looking at the profits. So this is looking at the partial profit. So what this was at, I just kind of calculated with this year's prices. So this would be $7.50 wheat, protein discounts and premiums at 5 cents a fifth, and then urea was at, I just calculated at $5.50 a ton, which was kind of around what the spring price was. So looking at profitability, there was significant differences, but looking at just like numerically, your highest profit was at 60 pounds per acre. And that 60 pounds per acre profit wasn't different than the 180 pounds per acre. That's kind of a trend that I saw through all of the locations, was the profitability really kind of petered off right after 60 or 120 pounds. So, and we did see that at one of the other locations too last year. So it wasn't just not a great nitrogen response here, and so unfortunately I don't know that much of that extra nitrogen that we applied, that expensive nitrogen that we applied this year, I don't know that it really paid off, but I think that was just weather. What do you do? Can't predict the weather, so that is what we saw kind of this year. Like I mentioned, I suspect that some of the response came from that deep nitrogen scavenging. Other next trial that we looked at was nitrogen-related trial, was looking at Pivot Bio. So there's been a lot of talk about Pivot Bio the last year or two. They've done a really good job pushing their sales campaigns. So they were kind enough to donate some products so we could test their wheat seed treatment. Their wheat seed treatment. And so what we did, the main goal was to see if we could replace 25 units of nitrogen with the Pivot Bio inoculant. And so what the Pivot Bio, I think, as I understand it, it's an engineered bacteria. So a lot of these biologicals, they're taking different strains of microorganisms, so primarily bacteria or fungi that are native in the soil. Generally, these could be strains that are found across the U.S. But I think what makes pivots a little bit different is that they actually have an engineered bacteria or engineered microorganism in what they're selling. So trying to replace 25 units of fertilizer. So we had a 100% N rate control, and then a second control minus 25 units of nitrogen, and then the pivot treatment was the minus 25 units plus the pivot treatment. The reps were kind enough to do kind of a living organism assay before planting. So they came out, they were really helpful. They treated all the seed for each of our collaborators. We had 4 locations this year, and then they also tested that seed to make sure that what they applied was indeed alive, at least when we applied it. And so they recommend planting within 2 weeks. So it's about a 2-week window that the bacteria will stay alive on the seed, which one of our sites, I just wanted to highlight Mentor. So everybody else planted within a few days of treating, but Mentor was they had a breakdown, and so they were really pushing that 2-week window. So the rep came out and resampled just to make sure that it was still alive. And so you can see their CFUs, that's just their measurement unit. It began at 6,700, and then about 10 days later it was at 720. So I think just to bear in mind that there is a shelf life with these biologicals. But the rep did say that even though it was a lot lower, they thought they still went with it, and they figured it would be fine, or they still green-light, I should say, let me say that a little bit better. They still green-lighted it because they said even though it's a lower amount, the bacteria were still there and alive to recolonize as soon as they got planted. So as soon as they get planted, they're going to start colonizing the roots and multiplying from there. So we didn't have to throw that location out. So there we had 4 locations this year: Stephen, Mentor, St. Hilaire, and Terrebonne, which is by Red Lake Falls. So in Mentor, Mentor and Terrebonne, they didn't get quite as much as the rain as some other places got, especially I know in the northern part of the valley, they got a lot more rain this year, but this year these guys didn't get quite as much rain, so it wasn't a real great yield response or nitrogen response year. So no differences there. Stephen was the one location I was really interested in, where I suspected, could definitely see that something was going on. So just wanted to look at yield. Statistically, it was a non-significant difference, but we could tell as we were harvesting just across the reps, you could see a pattern that the pivot treatment was actually keeping up with the 100% control, providing that extra 2 or 3 bushels of yield, and that was pretty consistent. So I feel like if we would have had, if we could have fit 5, 6, 7 reps into the field, it would have been I feel like it would have been a statistical response. But so I just suspect that it was actually something was going on to work in that field, and they definitely got the rain to get the higher yields, be a higher yielding environment. At St. Hilaire, they still got a decent amount of rain, but I think there was just it might have been an over-fertilization issue. There was no nitrogen response there. Even the minus 25 unit, there was no difference between the 100% control or the minus 25. And so if nitrogen isn't limiting, the pivot's less likely to respond. So I think we just had a little bit of a over-fertilization issue there. Terrebonne also did not get a lot of rain, and so we didn't see much of a response there also. So just to kind of summarize from this year, no significant yield differences. First season wasn't a great nitrogen response year, so that's why we do this in multiple years, so we can get different growing environments going. But I at least feel like something was going on at least the one location, so I feel like more research just to figure out in which context, what years and in what context these biologicals do work or don't work is definitely worth continuing. And just always, when we're talking about biologicals, just keep in mind that soil biology dynamics they're even more complicated than nitrogen cycling dynamics, and so it's going to take a lot of research to figure out these biologicals. So just be leery, or I shouldn't say be leery, keep that in mind when you're thinking about the biologicals and talking with the different companies. It's just, soil biology is a very complicated field that the scientists are still trying to figure it out too. Which kind of brings us into our second biological trial that we did this year. So this is a Johnson-Su bioreactor compost extract. So this would be kind of like doing a homegrown biological treatment, so to speak. So I mentioned before that a lot of the strains that the companies are using, those strains are probably already present in your soil, maybe in a less concentrated amount. So the idea with using this compost extract is that you're not just taking, a couple of the strains that are in the soil. You're applying the entire community that's living in the soil, and trying to throw the whole team at the plant instead of just a couple of the different players. So a Johnson Sioux bioreactor, it's a fancy name for kind of static composting. So it's aerated composting. So we want this to be aerated compost versus anaerobic compost. Anaerobic conditions are what create the bad bacteria. Those create the pathogens. So keeping it aerated is what facilitates, the good guys, helps the good guys grow. And just doing it in this way is just a way that you don't have to turn it. So it's just you build it and you let it sit. You don't have to turn it. So it takes a little bit less work and upkeep throughout the year. And so then ideally, so we set these up and you let them sit in compost for a year. That way they can go through, they can mature, the biology community, the community that's living in the compost can grow and then mature. And then so that way at the final end product that you get has a whole host of community of the good guys that you can apply to your crop. And so our objectives with this one were just to demonstrate how this could be done at a field scale for a farm application. And then I'm also working with U of M. So in Crookston, we're doing small plot research with this to determine if there's any nitrogen and phosphorus credits that could be used for using this extract. Because the whole idea is that we're applying microorganisms that can help scavenge or unlock some of the extra phosphorus and nitrogen in the soil that the plant doesn't necessarily have access to. So we have a fertilizer rate component to this, and then just evaluating, what's the diversity of the fungal and the bacteria species that we get out of this. And so we did, this was kind of a large plot, small plot experiment. So in our large plots, we originally had 3 sites, but only 2 of the cooperators were actually able to do the project this year. And the idea was that they all would have had the same 3 treatments, but that's not how the spring went. So in Crookston, we had 0 nitrogen, 50% nitrogen, and 100% nitrogen applied with the compost extract. In Red Lake, and this was on wheat. In Red Lake Falls, also applied to wheat. They had their controlled farmer fertilizer rate without extract, and then 50% nitrogen, 0P with the biology extract, and then no fertilizer with biological extract. Red Lake Falls, and so that was also wheat as a seed treatment. In Red Lake Falls, we had extra product, and so they put down a liquid in furrow test plot into their sunflowers. So they also had a sunflower plot that was just liquid in furrow with and without the extract, with no fertilizer treatments in there. And so we did do we sent the extract that we used in for analysis, and it had 985 different species of microorganisms in there. So there was quite a diverse number of biology going on. So we knew that we were applying something. We weren't just applying water. And we worked with, like I said, with the U of M. Small plot treatments was on wheat and soybeans. So the wheat was seed treatment and the soybeans had in furrow extract. The wheat also had 0, 60, 120, 180 pounds of nitrogen, and then 0, 20, and 40, and 60 pounds of phosphorus. So those were the different levels. So they had the whole combination of all those different levels of fertilizer. And then we also had different levels of phosphorus applied in the soybeans. Still working with them on their small plot, the yields and everything there. So and unfortunately, I don't have time to go through the small plot stuff too. So just focusing on the large plots. So that's kind of what it looks like to make one of these. We made 5 of them in a day, which 5 of them would pretty much cover all of your needs for the farm reparation for a year for sure. So we just mixed together a combination of wood chips, leaves, a little bit of horse manure, hay, and then rye straw. And that was all non-treated. So nothing had, the rye had no chemical residues on it, was unsprayed the previous year, the rye straw. Horses hadn't been wormed in a while, so the manure was clean too. So we mixed those all together, and those have been sitting, and then they've also get worms added to them at some point too, so those are actually up at Crookston. They've been doing a great job taking care of them, and as they've gone through the compost maturing process. And so we'll be using those this spring in our plots for 2024. This year we bought, for this last season in 2023, we bought vermicompost to kind of supplement some, so we didn't have any Johnson Sioux compost made for this year. We bought worm castings, basically worm poop, which is essentially what we're making with the bioreactors, to apply to our fields this year. And so these are just, it's better shown with pictures, just to kind of show the process of what we did. They do make, like, field scale, if you were to do this like field scale, they do make field scale applications, machines that do that for you, but we didn't need that. We didn't need that big of batches or have that equipment available. We didn't need batches that big to do just, 20 acres. So we only needed, 50 gallons and not 5,000 gallons. So this is kind of how we made our small plot batches. One of our Crookston cooperator was kind enough to source the supplies and build a seed treater and a extractor out of mixing cones, and then picked up some inline filters and hoses that we use from Spray Advantage in Grand Forks. And so using that, we were able to do the extraction process, and that's basically through really agitating and bubbling the compost to knock the biology into the water. So we were able to do that, filter it down to 50 mesh. You could filter it down to 80. I think we could have gone to 80 mesh, but we just needed to get it down to 50 mesh to get it through their planter, the screens on their planter, to keep everything clean. And so we were able to do that, so we didn't have to have plugging issues. And then for the wheat, we had just kind of a homemade, or a small seed treater that we built. So we seed treated by hand, just running the grain from one truck to the other. So we had to calibrated our grain flow and made sure we calibrated everything, trying to apply at a rate about 9 ounces per hundredweight on our wheat seed treatment. I'm pretty sure, I think I have all the rates and everything in the book for you guys. So that's kind of the process. It's hard to explain in a small amount of time. So if you are interested in it a little bit more, I can tell you all about it later on. So this year at Crookston, he did not get any rain at all. So their wheat yield was 30 bushels. I think every time the rain came over, it all went north and it said, "See you later." So, I mean, there was just zero nitrogen. When you have no response, nitrogen yield response to 100% nitrogen versus zero nitrogen, that kind of tells the story there. So he got no rain, so no yield. Obviously, we're not going to see a yield response with any treatments of any kind there. In Red Lake Falls, on the wheat, we determined that we needed we should have put one more control treatment in our field in the treatment list this year. So what I think we ended up with here was basically a nitrogen response trial, more so than an extract trial. We should have had zero nitrogen, zero extract control in there for sure. And I think that would have helped us tease apart a little bit some of our results. We picked these just on-farm projects can be hard when you're trying to do a lot of different treatments, and those treatments, that adds up to a lot of field space, the more treatments you add on. So these are the 3 we picked in the spring, and then hindsight's always 20/20. We should have had a 4th treatment in there. So I think we'll change it up a little bit for next year, so that we can better pull apart that data. So it's kind of a wishy-washy response for that. Sunflowers, though. So in sunflowers, we did the in-furrow extract. So it was just, we had the liquid and we applied it in furrow, and we did get a significant response. Granted, it was only 60 pounds. Sorry, it does say pounds per acre. It was only 60 pounds per acre, so it wasn't a huge yield response, but it was very consistent across the field that the plots with the in-furrow extract yielded about 50 to 60 pounds more than the untreated. So there was something going on there in that field. So we did see a response with the sunflowers. I think that had more to do, also benefited from being an in-furrow extract, which is the most efficacious way to apply these biologicals. And then the next step down would be seed treatment, and then probably the least efficacious way to apply these biologicals would be foliar applications. We did some extra testing, so we did tissue tests, we did soil tests for, nutrient analysis on the soil, and then also PLFA. I forget fully what it stands for, but it's basically trying to measure the amount of biological biomass in the soil. We didn't see any differences in that in the tissue or the PLFAs this year, so on the wheat sites. And so just as a summary, we're trying something different. This was a grower came to us. We had a few growers come to us that wanted to do this trial, so we gave it a shot. And then SARE is the one that was actually funding this trial. And so we're just going to keep playing with it and fine tune it and see if we can see what we can see doing it this way with the compost extract and how it compares, in the future to some of the stuff that's commercial. Just to quickly kind of flip through the rest, we did some rock rolling on wheat. Pretty straightforward. Some growers were interested in knowing, they've been doing it, and they were just interested in knowing if anything was going on. So it was rolled after planting, before emergence versus not rolled. We've had 3 locations over the last 2 years, 2 this year, 1 last year. This year, one of the sites yielded actually 3 bushels better with the rolled. The other sites were there was no yield differences. And the consultant for the site that did have a yield response, he was guessing that there was a little bit of soil crusting with the rock after the rock rolling, and he thought that helped keep the moisture in a little bit with the soil crusting. Although generally we don't want soil crusting, but seemed to be a benefit this year to keep the moisture in. But other than that, just with rock rolling, we haven't seen any negative impacts on the wheats for this year. So if that's something that, I don't know, down here, you guys probably have a lot less rocks than they do in the northeast part of our region. So maybe not as big of a deal down here as it is up there. Just to run through one of our cover crop trials, looking at 5 years of no cover crop versus a diverse cover crop mix. So this is just one location, one farmer that we're working with, or one operation. So they're looking at a corn, soybean, sunflower, wheat rotation. So cover crops are always interseeded into the row crops or after wheat in the wheat year. And this took place from 2019 through this year, and we'll finish up with the last of our soil health testing in the spring, this next spring. So in your books, you can see that they always had a very diverse cover crop mixture going down. So the idea was just to see if this cover crop, having a diverse cover crop mixture, what that does for your soil health. And so we had corn in 2019, followed by soybeans, wheat, sunflowers last year, and then corn this year. And so in the sunflower year, the corn, it was the rye. There was fall rye from the previous year that came back in the spring, and that spring rye really held the sunflowers back, really stunted the sunflowers, had poor stand. So big negative impact on the sunflowers. That was when we were planting. We didn't get planting till about June, end of May, June, and so the rye had just taken off. So it got too big and competed out the sunflowers, and had a negative impact on yield there, which actually carried through into the corn crop this year. So the cover crop plots did better, but we figure that's because there was less sunflower residue from the previous year tying up nutrients. So that probably had helped the corn crop this year versus an actual cover crop effect. And so we'll be finishing up with the soil health tests in the spring. So after the spring, we'll have a better look into if the cover crops had any effect on some of the soil biology, the soil health, and not just in addition to the yield. And so with that, I think I'm a little bit over, so I'm gonna have to speed up this week. Thank you guys. Thank you to everybody who's helped with this. I am going to be moving up to stay-at-home mom in March, so I will be leaving wheat. So they won't be able to hire a new person to replace me before planting season. And so our current plan is to put the on-farm trials on hold for this year, except for a few that are already in the ground or that need to keep going. I'll come back and help with those a little bit. And then as soon as they can get a new research director hired, we'll start back up with trials again. Probably either late 24 or the 25 season for sure. So, yeah, if you guys have questions, I'll be in the back all day. So, thank you.